and I'm just going to give you really some definitions and explain what they are. Pretty simple, straightforward stuff. All right, so let's start off with a solute and solvent. Those are the two parts of a solution. So we'll call a solute solid stuff that you mix in a solution. So a solution is usually water, and then you mix something into it. Let's say salt, sugar, iced tea mix, Kool-Aid, anything, right? Some solid mixed into water, you stir it up, that's a solution. So the solute is the solid stuff, the iced tea mix or the salt, or whatever it is you're putting there. If I put sugar in my coffee, that's the solute. Also, whatever came out of the coffee beans to make it coffee, that's also solute. Pour on, right?
No.
Yeah, you did.
Easy on your, right? Thank
Oh,
you.
all right.
Okay, come on.
I'm sorry.
Okay, so whatever the liquid is that you're starting with, that you're dumping your solute into, that's your solvent. Probably 95% of the time, actually even outside this class, it's almost always going to be water. Other solvents could be alcohol, paint thinner, nail polish remover, gasoline. Depends on what you're trying to dissolve, right? Something like gasoline will be good at dissolving grease. Water's good at dissolving most things that aren't fat, basically. And so let's put this here as a little side note. Water, or water, not the correct, is called the universal solvent. No.
Seriously?
Yeah.
Please?
No.
Thank you.
All right. So the reason it's the universal solvent is that water molecules are polarized. And so for that reason, when you throw something in the water, especially like an ionic compound, the sides of the water molecule, the positive or negative side, are going to grab onto those pieces and pull them apart. So we'll just add that in here. Because water molecules are polarized. Okay. Let's go on. Let's do concentration. Concentration. Basically, concentration is it's really solute divided by solvent. But you could think of it as how strong your solution is. You know, if you have a cup of coffee and I have a cup of coffee, and they're both the same size cup of coffee, and I put one sugar and you put two sugars, you're just going to have a higher concentration of sugar. If it's the same size cup. On the other hand, if we both have different size cups of coffee and we each put 1 spoon of sugar, whoever's got the bigger cup is going to have the lower concentration. Right? That kind of makes sense. If you put 1 spoonful of sugar into like a 32-ounce coffee, it's not going to be very sweet. If you put 1 spoonful of sugar into an 8-ounce coffee, that's going to be very sweet. It's a smaller cup. So more solute, higher concentration. More solvent, lower concentration. Okay? All right. Let's just write equals, actually. Basically. All right, last three, these all go together. There's unsaturated. So unsaturated means the concentration is less than the maximum possible concentration. Concentration is below the maximum. So for any solute, you're going to have a different maximum, a different saturation. So let's say with sugar and water, maybe you can put 10 grams into a cup of water, and that's the most you can dissolve. Or with salt, maybe you can put 20 grams into water, and that's the most you can dissolve. But with anything, there's going to be a maximum amount. And if you add more, it's just going to go to the bottom, right? You ever see somebody who puts way too much sugar in their coffee, there's just going to be like a pile of sugar at the bottom, because you can only dissolve so much sugar into water. And so saturated, and so you're like below that. This is unsaturated is way before you get to that maximum point. And then saturated is when you're at that concentration is at the maximum possible level. And you can tell a solution saturated if you add more and you see it all just go to the bottom, then you know it's saturated. You can't dissolve any more stuff. And then finally, last one is supersaturated. So I'll explain this one first and I'll write the definition. So for saturated, how much you can dissolve of something not only depends on what that solute is, but it also depends on temperature. So let's say, for example, you're making iced tea, and you have, I don't know, like a 16-ounce glass, and you put like 2 scoops in, and that's the most you can dissolve. It's saturated, right? And that's at room temperature. Well, if you heat that up, you can dissolve more iced tea mix in there, right? So you heat it up to where it's almost boiling, and maybe you can put 3 spoonfuls in there and dissolve it. If you do that, and then you let it cool back down, the iced tea doesn't come out of there. It stays stuck in there, even though it shouldn't be. It shouldn't be able to hold that much at that lower temperature. But since you dissolve the stuff at a higher temperature and let it cool down, it's like trapped in there. That's supersaturated. So we'll say when a saturated solution is cooled. And so here's a real life lesson. If you want to make your iced tea sweeter, make the water really hot, dissolve as much stuff as you can, and then cool it down. And it'll be stronger than if you try to make it when it's cold. Questions on this?
Can we try that?
Yeah, you can do that for like a lab.
Yeah.
I suppose. I don't know. I can write up the, you could probably do that. All right, I'm done. Questions?